In this section, we're talking about proportions and similar figures, and we're going to talk about identifying them and solving proportions for an unknown value, and then working with similar figures and solving applications. So a proportion is a statement indicating that two ratios are equal. So we've got a ratio here, we've got a ratio here, and we set them equal. And the way we say this proportion is to say A is to B as C is to D. Okay, so that's how you read it. There are two ways to verify if a proportion is true. One is just to use your knowledge of fractions. It's not always as simple. The other one is something that I try not to use very often because people often confuse it and use it in situations that it doesn't apply, but that is to use the cross product. This is a shortcut. I don't recommend it in all situations, but in some of these it actually does work better. So in this case, when I say use your knowledge of fractions, you can say, well, 3/4, if I have 3/4 and I multiply it times something, will I get 15 over 20? So remember, this something has to be the same thing top and bottom, because to make an equivalent fraction you have to multiply by 1. So if I look at this, I see, well, 3 times 5 is 15 and 4 times 5 is 20. So this is just multiplying by 1, which means this is true. So this is a proportion that is true. All right, the other way to do it is to use the cross product. So the cross product here is to say we're going to multiply these two, and then we're going to multiply these two, and we're going to see if they are equal. But I want to show you something, and I'm not going to do this every time, but I just want to make sure that you understand we're not doing anything new and tricky. This is just what we've been doing all along with fractions, and that is that if you take both sides times 4 over 1, then the 4 is going to cancel out. And then if you take both sides by 20 over 1, so we get 20 over 1 multiplied on both sides, then on the right side, the 20 divides out. So we end up doing what's called the cross product, which is this becomes 20 times 3 equals 15 times 4. So basically we just took these two and multiplied them, and then these two and multiplied them. So that's why it's called the cross product. There's nothing really magical going on here. It's just what we've been doing with fractions. So now you're going to take this cross product and you're going to say, well, this is 60. Does that equal the other side? This is also 60. So yes, this is a true proportion. Okay, so for the first example, we've got 8 over 18. Does it equal 4 over 9? That's what the little question mark means. Does it really equal? So I'm not even going to use the cross product for this one, because I can see right away that if I took 4 over 9 times 2 over 2, that I end up getting 8 over 18, which is what this side is. So this is true. So yes, this is a true proportion. So you don't even need to use a cross product when it's a simple fraction. Some of the fractions aren't nearly that simple, like this next one. So we've got 6 over 5.1. Is it equal to 4 over 3.4? So are those equal? So the easiest way to do these problems is to do the cross product. So I'm going to make one of them red, and I'm going to make the other one, we'll say purple. Okay. So the purple one, I'm going to say 6 times 3.4. Does that equal 5.1 times 4? Okay, so this was the cross product of 5.1 times 4. All right, so when you multiply those out, you should get 6 times 3.4 is 20.4. Does that equal the other side? It is 20.4. So yes, it does equal. Okay, I almost missed this one, so I just backed up to it. This next one is really complicated looking. 3.5 to 4 3/4. Is that the same proportion as 6 2/3 to 9 1/4? So you never want to have fractions and fractions, but remember, we're just dealing with ratios here, and proportions. So we're trying to see if they're equal. So the first thing that you want to do is you want to change these to improper fractions. So 3½ is 7/2. 4 3/4 is 19/4. Does that equal 20/3? That's 6 2/3. Over or per every 9 1/4 is 37/4. 37/4. All right, so remember that this is the easiest way to deal with these is definitely cross products. So we're going to do, I'll do, I guess, red, and we'll do this fun brown color. All right, so I'll do the brown one first, and so that one is going to be 7/2 times 37/4. And we want to know, does that equal the other one, the red one, which is, and it doesn't matter which one you write first, 19/4 times 20/3. Okay, so the best way to do this is just to use a calculator. So use your calculator, and on the top, on the left one, we get 258/8, and the right one we get 380/12. So now we still can't compare them because they have different denominators, so they're not really comparable yet. So just stick it in your calculator, and you're going to get 32.375 on the left, and the one on the right is 31.6 repeating. So are they equal? No, they're not equal. They're not equal at all. So you just want to check it all the way to the end and use decimals. Just use your calculator and compare it with decimals instead of fractions on these because they're pretty complicated. Now it is your turn to try it. And remember, it takes trying it to really understand it. Watching it doesn't really work. So give these a try, take your time, and then come back and look at the answers. All right, here are our answers. The first one, I just did it the way we've learned in past chapters, which is just to use our knowledge of fractions and least common multiples and things like that, and all of our factors. So 7 times 5 is 35, and 4 times 5 is 20. So yes, that one is a proportion. The second one I did cross multiplication, so 2.6 times 8 equals 5.8 times 4, and I get 20.8 is not equal to 23.2, so this is not a proportion. And the last one, remember to first put it into improper fractions and then do cross multiplication here. So I did one of them in red and one in green because it's kind of complicated. And you get to 285/8 on both sides. So they have the same, they're the exact same number with the exact same denominator, so you don't have to go further and put it as a decimal. So you can just say yes. So next we're going to do something that's done in algebra all the time, which is solving a proportion for an unknown value. So a proportion has 4 values, 2 numerators, 2 denominators. We can find one missing value out of these 4, which is what we're going to do now. So if you take a look at this first one, you'll see we've got 3/5 equals x over 20. So 3/5 is x over 20. So we want to know what x is. So what the book does is they do cross multiplication and just multiply both sides, and then you end up having to rearrange even more. So since x is on top, what we want to do is we want to just basically solve for x rather than cross multiplying. So I'm going to rewrite this just to give myself a little bit more space. So 3/5 equals x over 20. Notice x is on the right, but it's on the top. So all I need to do is multiply both sides by 20. The 20 is going to cancel out, and I'm going to end up with 60/5 on the left side. Well, 60/5, 60 is divisible by 5, so we get 12. So 12 equals x. Okay, so you can also do this by cross multiplication. So in which case I would have said, all right, these two are going to multiply and these two are going to multiply. So I'm just going to show you this a couple of times so that you can see that you're really doing the same thing. So we've got the green one, the red one is going to be 5 times x, and the green one is going to be 3 times 20. Then you have to take and divide both sides by 5 to get it back over to the other side, which is is kind of an extra step that you don't really need to take. So we've got 60 over 5 is 12, which we ended up doing the same thing, 60 divided by 5, just like we had set up over here. So sometimes cross-multiplying is a little extra work. Okay, so here's an example of you pretty much do need to cross-multiply because we have a W here on the bottom. So our W is on the bottom and we want to get it to the top. So it's going to have to be multiplied, and so is the 3. So when it's on the bottom, you're stuck with it. You got to do it. So we're going to have these two multiplied, and we're going to have these two multiplied. Okay, so I'll do the red one first so that my W is on the left. A lot of people like to see the variable on the left. It doesn't really matter, but that's what some people like, so that's what I'll do. So now we've got 3.6 times 3 on the right side. All right, so now that ends up being 2.4. W equals 3.6 times 3 is 10.8. Now you're going to divide both sides by 2.4. And you could have divided by 2.4 before you multiplied and got 10.8. That's fine too. There's lots of ways to do algebra, so that are all correct. So 10.8 divided by 2.4 is 4.5. These definitely require a calculator. It's a lot faster and more accurate, probably. Now, once again, it's your turn to give this a shot. So see what you can do with these. Notice the x is on the bottom on the first one, so you are going to need to cross multiply that one. The second one, you can cross multiply if you want, or you can just multiply both sides by 3.5. Okay, so here's the solution to this one. The first one, I did the cross product right away because the x was on the bottom. And you should get x equals 3. The second one, I noticed that y was on the top and it just had one number on the bottom, so I multiplied both sides by 3.5. 3.5 divides out on the right and you're left with y by itself. So I just switched sides. I put the y on the left just because that's what we're used to seeing, and said y equals 3.5 times 2.8 divided by 2, which is 9.8 divided by 2, which is 4.9. Or you can do the cross product, which gives you the exact same thing. I just took 2.8 times 3.5 equals 2 times y. Then I had to divide by 2 on both sides, and y equaled 4.9. So either way, the same thing happens in the end. Okay, I'm going to end this video here and call it 6.2a, and then I'll start with the next section in the B video. This one is going to be working with similar figures. So go to the next video for this one.